Hello again, students. In this video, we're going to be looking at SOL G5 Part C, which asks us to determine whether a triangle can exist. Let me show you what that looks like. A very, very, very important theorem, which is totally worth you knowing and memorizing, is the triangle inequality theorem. The triangle inequality theorem says in order for a triangle to exist, the small side plus the medium side of a triangle must be greater than the large side. Now, I know you have a lot of theorems rolling around in your head, a lot of formulas rolling around in your head. This one is not given to you on the SOL, and yet it is one you really, really need to know. The triangle inequality theorem. In order for a triangle to exist, the small side plus the medium side must be greater than the large side. So, here's some different examples of how this may be asked. Here I've got a problem that says, circle each group of segments that could form a triangle. Now, a lot of times students want to do the Pythagorean theorem here. But notice it does not say form a right triangle. It just says form a triangle. So it could be any kind of triangle. Obtuse, scalene, does not matter as long as it forms a triangle. So I'm going to use the triangle inequality theorem here. I need to identify the small side, medium side, and long side. So in this set, 8, 5, and 11, 8 would be the medium side, 5 would be the small side, 11 would be the longest side. And I need to do a simple check. Does 5 plus 8 add up to more than 11? Yes, 5 plus 8, that's 13. And 13 is more than 11. So this is a side length combination that could form a triangle. So I'm going to highlight that one. Down here, 7, 7, and 7. Whoa, okay, no short, medium, or long, so I'm just going to identify short, medium, and long. Here, this would be an equilateral triangle, a triangle where all the sides are exactly the same. 7 plus 7, that makes 14, and of course 14 is more than 7, so we're good to go. An equilateral triangle there. All right, my next problem here, I've got 4, 2, and 6. 4 would be the medium, 2 would be the small, 6 would be the long side. And if I add up the small side and the medium side, I get 6. 6 is not greater than 6. So this one's out. Moving on to the second column, 20, 1, and 14 are the three side lengths that I'm evaluating. 20 would be the longest side, 1 would be the short side, 14 would be the medium side. Add the short side and the medium side together. 1 plus 14 is 15. 15 is not greater than 20. That's out. Next group, 13, 6, and 11 are the three side lengths. 13 would be the long side, 6 would be the short side, 11 would be the medium side. Add up the short side and the medium side. 6 plus 11 is 17. 17 is greater than 13, so I found another set. These three can form a triangle. And last but not least here, we've got 8, 3, 3. 8 would be the long side. 3 and 3 is a tie, so I'll call it short and medium. Do the two small sides add up to be more than 8? No, 3 plus 3 is 6. 6 is not more than 8, so that set could not form a triangle. So in this group, I've only got 3 that could form a triangle using the triangle inequality theorem. You do have to identify all parts correctly in order to get that question right. The SOL does not accept partial credit. So you could not get just one of them or two of them. You'd have to get all three sets to get that right. Okay, next example of this I have is more of a word problem. It says 4 boards were given to Sam to build a triangular picture frame for a large painting. Very interesting, triangular picture frame. Okay, the side lengths we've got here are 8 feet, 12 feet, 21 feet, and 32 feet. Which boards can Sam use? Well, he's building a triangle, so he's only going to use 3 of the 4. So we have to figure out which 3 would form a triangle. So let's run a couple tests here. Let's try to use 8, 12, and 21 and see if they could form a triangle using the triangle inequality theorem. 8 would be small, 12 would be medium, 21 would be large. Is 8 plus 12 greater than 21? Well, 8 plus 12 is 20, and 20 is not greater than 21, so that combo's out. Okay, in fact, A, B, and D would also be out. 8 plus 12 is also not greater than 32. If it's not greater than 21, it's not greater than 32. So that combo's out. So ABC is out, ABD is out. So let's see if we can use, let's throw A out. Maybe that's too short. Let's try to use BCD. All right, so 12 would be the short, 21 would be the medium, 32 would be the long. 12 plus 21, is it greater than 32? Well, 12 plus 21 is 33, and 33 is greater than 32. We found a combo. So my final answer here, we can use boards B, C, and D, and they will form a triangle. B, C, and D. Okay, I hope that was a good explanation of the triangle inequality theorem. We're going to see it again in the next video. Come back to explore SOL G5 Part D.